Okay, today we are going to just record a demo that we are going to do using this welding robot, and we are going to do every step from scanning and just welding different passes. And here we just turn on the robot, and then Martin's in here is just going to use the HTML, kind of like a human interface HMI he created to just operate the robot. So first we are going to just put it in home position, which essentially extends the laser arm to reach to the specified location. Because the more near we are to the pipe, the more accurate is the scanning. And afterwards, after this it's fully extended, I'm going to put the robot in home position. I mean, we have installed a home sensor, but still it's a work in progress. And so for now I'm just using this technique, just manually putting in home position, but afterwards this part is going to get automatic. And now that we have put it here, Martin is going to set the parameters. He's just going to scan for 120 degrees, and he's just going to scan with 0.5 RPM as you can see, and then he's just going to start the scan. But before that, we should just put the laser in scan mode, and to know what, for example, what's our degree of scan, he's just going to put it in the scan mode, and then he's just going to start rotating. And when it's scan mode, as you can see, the laser is turned off. But when he starts rotating, you can see that the laser is going to get triggered, as you can see, and this trigger is every 0.5 degrees. So we are just recording data every 0.5 degrees, and essentially by 120 degrees of scanning, we are going to scan the first part of the groove. We are using the first part because this part doesn't have any weld, so we can easily just compare the results when we add some welds, which is essentially the second pass, and then to see if the robot is working fine or not. So it's just going to fully scan. Then it's going to go back to the home position, and afterwards this data, they are going to get processed. And first we are going to remove the outliers, just remove the noises and outliers. Then we are going to do a piecewise linear fitting to just get the groove, and afterwards we are just going to send the data to the Raspberry Pi and to the controller, and then we are going to do kind of the first weld. I'm just going to show everything live. I mean, currently it's getting the piecewise linear fitting. Yeah, this part is kind of the most the part which consumes the most of the time, because just fitting piecewise linear, just doing the piecewise linear fitting, that's require a bit of calculations, and yeah, that takes a while. In the meanwhile, I can just show you the HMI. As you can see, we have different parameters like scanning, scanning parameters, and then welding. As for the scanning parameter, for example, in here we just set it to 120, and for welding we can just define the initial position, the final position, and also that's the offsets. For example, how much we want to offset the torch from the surface. and currently, and also we have just the rotation speed. For scanning we just used 0.5 rpm for forward and backward, but for welding we can just go to slower speeds. And we can also define the weaving motion, which is kind of the sinusoidal movement. And in here we can just turn on and turn off the motor, and we have a kind of protection which comes in if in case something goes wrong. And also we have another screen for turning on and turning off the supplies, and also controlling the torch. Okay, so the fitting was done. As you can see, the step 3, which was the fitting, was done, and it took around 138 seconds, which is around essentially 2 minutes. Now the files are going to get sent.
We have to upload it first.
Yeah, now oh, it hasn't finished. Okay, yeah.
This is like the second fitting.
Ah,
This
okay,
is the
okay.
piecewise
Yeah, this is the
fitting.
piecewise inner fitting. The piecewise inner fitting was done, and what's the second part?
Oh, the second part is actually this one. It's actually been done. It's
Yeah, that's
this fitting like for the points.
okay. So these are, as you can see, these are the, for example, the middle points, the height, and the kind of the height, the Z and X. And yeah, now kind of everything has finished, and we have found the middle points.
Upload the files.
Now the files are going to get uploaded, and afterwards you can just start the scan. Start the weld. Yeah, just going to put it here. You can see the files. The files are being sent. Okay, and the trajectory is fully sent from the Raspberry Pi to the controller. And then now I guess everything is ready. And now Martin is just going to put it in weld mode. So in weld mode, this arm is going to get extended. And then just going to find the middle point and
Let's change the parameters first for
yeah.
rotations.
Yeah. Just so in here we are just having a weave motion, and we are trying to keep center and also control the height at the same time, because the height is also changing. And these are all based on the scan we did recently. To just show that it works in both directions, it was, for example, upward welding, but when it goes backward we are also going to do the same control. So this robot is just capable of doing both upwards and backwards. Okay, after this part is done, now we are just going to put a part to just emulate a weld. I'm just going to put this just as a way to simulate that. For example, during this we have welded this part, and we are just assuming, okay, we partially welded this groove, and then now we are going to scan again to and detect this weld, right? We're going to scan again, detect this weld, and then we are going to do the second pass, and we should see if the torch is working fine. This part, this should operate a bit quicker, because now there is no need to do the piecewise linear fitting again. The piecewise linear fitting is just to find the groove, to find, for example, how is the shape of the groove, and then we are going to use that one to compare, and based on this comparison we can just find which parts has welds in the second pass. So again we just put it in the scan mode, and now we are scanning for the second time, which is kind of for the second pass. Again, we are doing it every 0.5 degrees. As you can see, that's the okay. After the scan is sent, then a scan is done, then again the data after storing the data is sent to the controller, and then the comparison is made, and then we can run the motor for the second turn. And as you can see, for example, at the beginning we are just removing the outliers, and then in here
Here it's kind of like just looking at the encoder values,
okay,
so that it can
okay, do the comparison.
know when it is
Okay.
finished at the home position.
Yeah.
But it finished the processing, it has removed the outliers already.
Yeah.
It's just that before sending the data,
Yeah.
we want it to be at the home position.
Yeah. Yeah, that's true. Now currently, if you can see, we have just reached home position again.
And then once this stops, then it will start sending the data.
Yeah, then it's
And now here it knows it has reached like the home position.
home position, yeah. Okay, now as you can see, automatically it just sends the data.
And then you should see something change here.
Yeah, and
Light blinking on the
Yeah.
HMI.
so whenever the light is blinking, right,
It means there's new data.
new data is
Yeah.
received, yeah. So we have this, yeah.
Received, so we can change to the welding mode.
Okay,
Yeah.
but it's sending, okay,
Yeah, just to send two times.
two
just to
times,
make
okay,
sure.
just to make sure, yeah,
Mhm.
nothing is missing.
Mhm.
Okay, now we have put everything, then we have just sent everything. We are going to put it in welding mode again. So in welding mode again, the arms are going to now that we have reached the weld, as you can see, it's retracted. And it's still, I don't know if it's visible or not, it's very near to the weld, but that's how we program it, but it's not touching. So we are just keeping the minimum distance. So, and we could detect the weld. and we can continue it for as many passes as we want. For example, if we add another weld, we can show that okay, it's going to operate fine again. And also going, as I said, it's going to work both in forward and backward directions, upward or downward. Now after just reaching the final point, yeah, it's going to just go backward, and when this weld is finished, yeah, it's going to get more near to the groove. Yeah, that's kind of that was just a small demo that how everything works in real time. And as by yeah, now we're just putting back everything in home position, so every arm gets retracted, and then we're assuming the robot work is done, for example, after doing every passes. And yeah, one of the things that we are working on is just adding the home position, and as you saw, we had to just do it manually for now, but we are just working on the home position sensor, and hopefully we can just, when we are going to do the demo in person, everything is going to be automatic and there is no need for manual adjustment. But other parts, as you saw, everything works fine. Thank you for your time, and yeah, have a good day.